Hello everyone, this is KK Matics, the solution to your mathematics. Today we'll be dealing with relations and functions part 3. The subtopic we'll be dealing with today is relation and function 3. Under this lesson we'll be dealing with types of functions and one-to-one functions. Types of functions. Number one function we have to talk about is what we call the one-to-one function. Now I'm talking about one-to-one function. One-to-one function is actually a function that maps from x to y, and we say is one-to-one if different elements in set x have distinct images in set y. So what that means is this. So in mathematically, what we mean is if you're given a function, okay, and in this function if we substitute a in the function, okay, and substitute b in that same function, so that is to say that what if f of a equals f of b, that implies a equals b. That is to say that what our end result should be equal to what should be that a be equal to b. This is what we mean here. This is an illustration, and this is a one-to-one function that is mapping from 1 to what? A distinct image in set X. This is a distinct image in set Y, sorry, and this is our function. So as you notice, all the elements in its domain have a distinct or different image. Okay. Let's consider an illustrative example here. Now, show that the function here, so we have a function here where the function maps from x to 1 out of x minus 3, where we have that x is not equal to minus 3. So we are to show that this function is one-to-one. And so to do that, the first thing we do is first equate the f of a to be equal to f of b. So we're going to use this function here, as you can see there. So with this function that we have here, we're going to use this function. So using this function, we have what? So wherever we have our x, we replace it with a. So as you can see, f of a, so we have the function of f of a, and that's what? We replace the x with a, and that's what we have there. And from there, we move on to f of b, and replace the x with b for f of b. So right after doing this, the next thing we do is to equate them. Equate f of a to f of b, as you see here in the diagram. As you see here, sorry, in this illustration. So we have 1 out of a minus 3 be equal to 1 out of b minus 3. So the next thing we do is to cross multiply. That says that what? In cross multiplying, the b minus 3 goes to multiply the 1 at the left hand side, and then a minus 3 goes to multiply the 1 at the right hand side. And by so doing, we have b minus 3, and that be equal to a minus 3. And so as we know, this minus 3 here goes to the right hand side, and it becomes positive, and we end up cancelling the 3. And this leads us to having a be equal to b. B equal to a is the same as a equal to b. And so we've proven from this that what? If f of a equals f of b, this implies that what? A equals b, and therefore this function is one-to-one function. And so we've proven that. Another illustrative example. Show whether or not the function defined by g mapping from x to 1 out of x squared plus 3 is one-to-one. Obviously, we can tell that this particular function is not one-to-one. Now, we will prove that. However, one of the quick way of determining that is whenever you have an x squared, okay, now one-to-one function tend to what? The earlier one had a different function. This particular function, we have x squared here. So x squared here is going to be a problem because we'll end up having what? Two values of a and b. Probably you don't know what I'm talking about, but as we move along you understand. So let's prove that then. So the function is 1 to 1 if what? The g of a equals g of b, which implies a equals b. So for us to do so, what we do is to find g of a. So wherever we have our x, we replace it with a. And wherever we have our b, wherever we have our x, we replace it with b for the g of b. And that is what we've done there. So from here, the next thing we do is equate g of a, as you can see on your screen here, to g of b. So by so doing, we have what? 1 out of a squared plus 3 equals 1 out of b squared plus 3. So from here, we cross multiply. And cross multiplying, we have what? B squared plus 3 going to the what? Left hand side to multiply the 1. And a squared plus 3 goes to the right hand side to multiply the 1 there. And so the next thing we have is what? B squared plus 3 being equal to a squared plus 3. And since we take the 3 to the other side, which is the right hand side, it becomes negative, and therefore it cancels or takes off the 3, making giving us a 0 value. And so we end up with b squared be equal to a squared. And obviously we said earlier on that what? A function is 1 to 1 if what? G of a be equal to g of b implies that what? A equals b. And here we have b squared equals a squared. And therefore there's a need for us to find the b or a. And so by so doing, we end up getting b be equal to what? Plus or minus square root of a squared, which is equal to plus or minus a. Remember, our value for a is 1, and the value for b is 1. We have a be equal to b. Therefore, with this, we then will say this function is not 1 to 1, since it has two values. That is b equal to a and b be equal to what? Minus a. Therefore, it's not 1 to 1. Another illustrative example for us to consider here. Now, we are told to show that the function of f mapping from x to x squared minus 9 or divided by x squared, where we are told that x is greater than 0 is 1 to 1. So here, one thing we need to have in mind in here is that we have been given an instruction that the value of x is greater than 0. So therefore, if we get any value of x that happens to be what? Negative, we are not going to consider it. We'll just what? Ignore it. Because here, we are told this function is a function where the x value is greater than 0. And we are to show that this function is 1 to 1. Therefore, in showing so, the function f is 1 to 1 if what? F of a equals f of b, and that implies what? A equals b. This is the what? This is the formula we use. And so all we have to do now is to what? Find f of a and find f of b. And that is what we've done there. So the next thing we do is equate both equations or both expressions. So by equating both expressions, this is what we have. And as you see, we cross multiply. B goes there, a squared goes there. And this is what we have here. And so, and we are left with this. A squared b squared minus 9b squared. This equals a squared b squared minus 9a squared. And obviously, as we can see, this is similar to that. So if we take one of these, that is a squared b squared, to the left hand side, it becomes what? It erases the other a squared b squared, giving us a 0 value. Now, we'll be left then with what? Minus 9b squared and minus what? 9a squared. And since we cancel the minus from each side, which is the left hand side and right hand side, we are left with 9b squared be equal to 9a squared. And in here, we can still cancel the 9. So if we divide this side by 9 and divide that side by 9, we end up having what? Canceling the word 9. So this is what we did. So this cancels that, and we know that this 9 will cancel this 9. And we'll be left with b squared being equal to a squared. So this is what we have there. So we have that b equals what? Plus or minus square root of a squared. and b equals what? Plus or minus a. Remember we said earlier on that what? The value of x is what? Greater than what? 0. Therefore, we say that what? A equals what? B. Okay, it's important. We will not consider the negative aspect of the values because x is greater than 0. Yes, therefore the function is 1-to-1. On another illustrative example, I want you to try your hands on this and see. Let's see whether you understand. Okay, so by now I'm sure you're done. So let's go through this. So this is the function we given. We told that what? We given the function were what? Function of g mapping from x to x squared plus 1. And this is the domain we're given. What is 1, 2, and 3? Use an arrow diagram to show whether or not the function is 1-to-1. And obviously with this particular function here, yes. So this is the mapping, and since each member of the domain has what? A distinct, or let me say a different image in the codomain, the function is 1-to-1 function. Now, attention. It's very important as you have what? It's important to note that what? Now that you understand the concept, it's important to solve at least 12 examples continuously under this lesson to be perfect in this lesson before moving to the next lesson. And of course there are consequences for not doing that because you will forget it if you don't revise. It's important to revise it. And thank you for your attention. This is the end of the class. The next topic will be relations in function 3. Bye for now.